All right, so hopefully you've had a chance to be challenged to do a long division question, and maybe some people in the class were able to answer the question really, really quickly. Those people probably, even though they're really, really good students, were probably using something called synthetic division, which is kind of like a shortcut for long division. It's something that is like TV tray. It's like a gimmick that you put off and do off to the side that allows you to answer a question really, really quickly. So I'm going to let you in on the hint, and those people who were here and heard about it can help the rest of the class with this. So we're going to do it with this question. So first I'm going to do it the long division way. So we ask ourselves, what do I multiply by x to get 3x cubed? It's 3x squared. We know then that we have to multiply that, a little mini rainbow, 3x cubed. 3 times negative 3 is negative 9x squared. We have to subtract. It's negative 5 minus minus 9, which reminds me to add, so it ends up being 4x squared. Bring this down as a minus 7x. What do I multiply by x to get 4x squared is a plus 4x. 4 times x is 4x squared. Minus 12x. We subtract again, so it's negative 7 minus minus 12, which is a positive 12, so it's plus 5 in total. Bring down the minus 1. And then I ask, what do I multiply by x to get 5x? And it's plus 5. 5 times 5x, or 5 times x is 5x. Minus 15. Negative 1 minus minus 15 is like an add 15. And I get a positive 14, which is a remainder of 14. So the long division is still good. Now, even though you're going to see this shortcut, you still have to know how to do long division. On the test, there's going to be a question that says use long division to do this, because the shortcut method doesn't and isn't the most efficient method all the time. So we can't lose sight of this. So even though we're going to learn a nice new shortcut that we'll probably use quite a bit, we can't lose sight of knowing how to do it long division wise. But this synthetic division is really, really handy. So we set it up off to the side, make this little L shape or whatever. And the top line of synthetic division is the coefficients of my question. So if we look at this, we just write down the coefficients. So we write down 3, negative 5, negative 7, negative 1. Those coefficients just go along the top line of this little division thing. Then we look at what we're dividing, the divisor. In this case, it's x minus 3. So what we write down is we write down the root of the divisor. So we ask, what do we multiply, or sorry, what do we put in for x to get a 0? That's the root. Since it's x minus 3, the root of the divisor is 3. So we write down a plus 3 there. Had this question been a plus, our number right here would be negative. But in this case, we're dividing by x minus 3, so we write down a plus 3. And now, we're all set to do the synthetic division. Step 1, this number just gets copied straight down as is. It's a 3. Then, our next number is what we do is we take the divisor of this root, we take 3 times 3, and we put our answer up here into a 9. So it's 3 times 3, we get a 9. So we just write down this 9. Next, we look at the next column, this next column, and we add them. Different from long division where we subtracted, here we're adding. So we're going to add negative 5 plus 9. This is another advantage of synthetic division, is we get to add. Far less mistakes when we add than when we subtract. So negative 5 plus 9 is just a plus 4. And we write down our answer there. Next, we follow the same process. We take our 3, we multiply it by the 4, and we put our answer up here. So 3 times 4 is 12. Next, we add again. So add these. 12 and negative 7 is 5. And repeat. So 3 times 5, put our answer up here, is 15. Add this column. So we've added, add again, and we get negative 15 plus, or sorry, negative 1 plus 15 is 14. And then what you'll see is your answer will all be in here. But I kind of work backwards. The last number is the remainder. So I circle it just so there's no confusion. If you compare it to our actual long division, we see the remainder is 14. And then each of these places work backwards to fill in all the spaces. So this 5 here is actually the constant 5. This 4 is the one with the x. And this 3 is the x squared. And so you can look at it and see all those places and say the answer is 3x squared plus 4x plus 5 with a remainder of 14. Now that took some time because as I was explaining, I had to walk through this really quickly to explain all the steps. But reality, this is a much quicker method. So if I was actually doing this, knowing all the steps, I could write down the coefficients, 3, negative 5, negative 7, negative 1. The root is 3, so I just do this, bring down the 3, multiply is 9, add is 4, multiply is 12, add is 5, multiply is 15, add is 14. There's the remainder, and the number is 3x squared plus 4x plus 5, remainder 14. And it's really quick. All right, so we've got a new question here that I'm going to set up, but then give you guys a second to try. Now, remember when we did long division, we had to do all the same rules about making sure all the letters are there and that they're in order. So in this case, the degrees all in order, everything's good, but you notice we're missing an x. So we're going to have to add a 0x in there. So when we set this up, we'll write down the coefficients as 2, 3, 0, and negative 5. And then, what's the number that's going to go here? Plus 2, thank you, Ty. So it's the root, so we put a plus 2. So you're all set up, so try quickly, see how quickly you can do it. If you need to pause the video to give the class a chance, go ahead. Okay, hopefully you've had a chance to try it. And we'll just go through the steps. The 2 goes down as 2. We multiply 2 times 2 is 4. Add these is 7. 2 times 7 is 14. Add this is easy as 14. 2 times 14 is 28. Add those is 23. The remainder is 23. And so therefore, my answer is, I can work backwards, 2x squared plus 7x plus 14 with a remainder of 23. Okay, a much more efficient and quicker way to get the exact same quotient or answer that we want. Okay. Just for the video, I'm going to have a third one up here. You can push pause right now, give a third chance at this. I'm going to go right ahead and answer it, as is the class here in front of me. Of course, notice in this one it's slightly different because the root is going to be a negative. So I've got to put a negative 3 here. How do my numbers look? Same as you? Ty Tebow agrees. Thank goodness. And so I got 5x squared minus 12x plus 35, remainder negative 96. Anyone else get that? Same numbers? Yeah? Okay. So it's a great method. Obviously, if we had to do long division on this, it would take much longer and probably a greater chance for making mistakes. There is a hesitation, though. It's not always the most efficient method. Here's an example of one in which it's not the most efficient method. 6x cubed plus 5x squared minus 15x plus 1 being divided by 2x plus 3. So the problem in this one is the root is a nasty fraction, negative 3 over 2. So if we try and use this synthetic division, 6, 5, negative 15, and 1, and it's negative 3 over 2, you can see how the math isn't quite as easy. It will still work, okay, except now you're multiplying fractions and so forth. Okay, and if you need to add the fractions, it becomes even more of a challenge. Okay, now this one's not bad. It's negative 9. Add this as negative 4. Multiply this as plus 6. Add them as negative 9. But here it's not quite as nice. It's 27 over 2. And when we add those, we need to find a common denominator. So that's 2 over 2 is 29 over 2. And there's your remainder. So we kind of lucked out in some of the numbers, but it doesn't always work out quite as nicely. You can imagine, had this been the other way around and been like a 2 over 3, all of these numbers here would have been fractions, and you would have had to find common denominators. So it's not the best method all the time, but for most of the math we're going to be doing, the synthetic division is going to be what we want to use. Okay, so you can try a few of these on your own at your own time. Page 169. Number 6.